Hello friends, in this video I'd like to solve the following problem from the Polish Mathematical Olympiad first round 2023, problem number 5. Let n be an integer such that n minus 3 is divisible by 7. Show that the sum of cubes of positive divisors of n is also divisible by 7. So my hints for you for this problem. First of all, 7 is a small integer. So you can manually check when the product of two integers is congruent to 3 modulo 7. A second observation is that some number d divides n if and only if n over d divides n. Sorry, there is a typo. Divides n. And last observation is to consider twice the sum of cubes of d. So give it a try and see you in a moment. Okay, so first of all, I prepared already this handy table of multiplication modulo 7. What does it say? So for example, minus 3 times minus 2 is minus 6. Minus 6 is plus 6, sorry, plus 6. Plus 6 is congruent to minus 1 modulo 7, so I wrote here minus 1. Another example, minus 1 times minus 3 is 3, and 3 is congruent to 3 modulo 7, and so on, so on. Crucial observation, I highlighted numbers 3, remainders 3 in green, because n minus 3 is divisible by 7 if and only if n is congruent to 3 modulo 7. And now we see that product of two numbers can be congruent to 3 if and only if one number is congruent to minus 1, the other to minus 3, or the other way around, or one is congruent to 2, another is congruent to minus 2, or other way around, or last option is when one number is congruent to 1 and the other number is congruent to 3 modulo 7. But, so I will write it down. So AB is congruent to 3 modulo 7 if and only if A is congruent to minus 3, B is congruent to 1, to minus 1, or the other way around, or one number is congruent to minus 2, the other is congruent to 2, or one is congruent to 2, other to the minus 2, or one is congruent to 1, the other is congruent to 3, or one is congruent to 3, the other is congruent to 1. Of course, modulo 7. Everything is modulo 7. Now, the crucial observation. Let's notice that minus 3 cubed plus minus 1 cubed is congruent to 0 modulo 7. Likewise, minus 2 cubed plus 2 cubed is also congruent to 0 modulo 7. And finally, 1 cubed plus 3 cubed is also congruent to 0 modulo 7. So every time we add cubes of two numbers whose product is congruent to 3 modulo 7, every time we get a congruence to 0 modulo 7. Now, let's consider 2 times the sum over all positive divisors of n of cubes of d cubed. So we can write it as 2 separate sums, and the other sum, instead of d cubed, I will write n over d cubed. Okay, and I will combine it in a single sum. d cubed n over d cubed. Okay, and now, very important, by our observation, by our notice, it doesn't matter which divisor d we are considering. Every time d cubed plus n over d cubed, every time it's congruent to 0. So we have sum of zeros modulo 7, and sum of zeros is of course congruent to 0 modulo 7, which means that 7 divides 2 times our sum of d cubed. And finally, 2 and 7 are co-prime numbers. They have no common divisors. So it means that 7 must divide our sum of cubes, which was exactly our goal, quadrant demonstrandum. And that closes our video. So thank you for watching. I hope that you learned something new, and see you next time. Bye!